There are lots of different relationships between our number system and algebra. In a number system, if we add 0 to a number, the number stays the same. The same works for algebra. If we multiply a number in our number system by 0, the same happens in algebra. If we multiply a number by 1, the answer is the same as the original number. The same goes for algebra. Any letter that we have, any pronumeral, we multiply it by 1 and it stays the same as the pronumeral. We have cumulative laws, and basically that means we can swap the order of certain kinds of number sentences around and get the same answer. When we have our numbers, if we add 2 plus 4, we get 6, and if we swap the order, it stays the same. That works for all of our numbers. It works similarly for algebra. If I add A and B together, it's exactly the same answer as if I added B and A together. So adding can be done in any order. If I subtract numbers, if I do 2 minus 4, I get minus 2. If I swap the order around, 4 minus 2 is a positive 2. So the cumulative law doesn't work for subtraction. So that means A minus B can't be equal to B minus A. So our subtraction must be completed in the order that's given to us. If I multiply 2 lots of 4, I get 8, and the same as 4 lots of 2, I get 8. And you can see that with the dots there. It doesn't matter what way we put it, we still end up with the same amount. So A times B is the same as B times A, so our multiplication can be done in any order. When I do division, 2 divided by 4 is a half, or 0.5, but 4 divided by 2 is 2. So we get a different answer when we deal with our number system, and similarly for algebra, if I have A divided by B, it doesn't equal B divided by A. So the dividing must be done in a particular order that's given. So our commutative laws are focused around our addition and our multiplication. So we can do them in either order and get the same answer. Another kind of law that we have in our number system is our associative law, and that's saying that we can group certain processes together and get the same answer. So if we have a look at addition, that means where I have the brackets here, let's say if I had a number sentence that just said 2 plus 4 plus 5, it wouldn't matter if I added the 2 and 4 together first, because that would have given me 6 plus 5, which is 11, or if I added the 4 and 5 first to get 9, and I would still end up with the same answer. So it doesn't matter which part of the number sentence I do first. So similarly with algebra, if I had a statement that had A plus B plus C, it wouldn't matter if I added the A and B first and then added the C, or if I added the B and C first and then added the A. So adding can be done in any order. Okay, so it doesn't matter what order they're in. If I have subtraction, so if we have a look at this first one, if I had 2 minus 4 minus 5, if I did the 2 minus 4 first, I'd get minus 2. Then take away the 5, I would get minus 7. If I swapped the order around and did the 4 minus 5 first, that bit there would give me minus 1. So I would have 2 minus minus 1, which would become 2 plus 1. It gives us an answer of 3. So our cumulative law doesn't work for subtraction. So this statement over here won't work for our algebra. So we have to have them in a particular order that's given. When we're multiplying, we can, multiplying in any order will work, because if I've got 2 lots of 4, so 2 lots of 4, and then I've got 3 of those, so 2 lots of 4 is 8, 8 3 is 24, or if I have 4 lots of 3, so I've got 2 lots, and 4 lots of 3, I've got 2 of those, so 2 lots of 4 3s are 12, I still get 24. It doesn't matter what order I multiply in. So over here, if I do the A and B first, or if I do the B and C first, or even if I did the A and C first, it doesn't matter what order. When you're dealing with division, if I had a statement that said 12 divided by 2 divided by 3, if I did this first, 12 divided by 2, I'd get 6, divide that by 3, I get 2. If I did the same statement, but then did the 2 divided by 3 first, that gives me 2/3, 0.6 repeater, But when I do the division here, 12 divided by 2/3, I actually get 18. So two completely different answers. So that means the order of division has to be done from left to right if you've got a number of them in the particular order that's given. So A divided by B, then divided by C doesn't equal the same as this side. So division must be done completed in a given order. So the associative laws work out for addition. So it doesn't matter the order for addition, and it doesn't matter the order for multiplication. We also have a distributive law. So what that means is if I've got 3 lots of 2 plus 4, for example, it's the same as if I multiplied the 3 by the 2, 3 2s, and the 3 by the 4, 3 4s. I would add them together. So you can see here, 2 plus 4, this bar represents 2 plus 4, and I've got 3 of them. Here, 3 times 2 is the blue, 3 times 4 is the yellow, and if you counted them all up, you always end up with the same amount. So that's the distributive law. So it's going 3 lots of 2 plus 4 is the same as 3 lots of 2 plus 3 lots of 4. Okay, so you get the answer of 18. So the 3 is distributed across the 2 plus 4, turning it into 3 times 2 and 3 times 4. And in algebra, we write it like this. So we have the A out the front, times in the brackets B plus C, so we're timesing it. So it's kind of like you think of like an arrow, A times B, A times C, and because there's a plus there, there's a plus there. So we use that with our numbers, sometimes if we're breaking up a particular number multiplication. So if I've got 6 lots of 204, I can think of it like this. It's the same as the 6 lots of the 200, breaking the 200 into 200 plus 4. So 6 lots of 200, we work that out, 6 lots of 4, work that out, and then add it up. So we can use the distributive law to help us with multiplication. Or if I had a question like this, in the purple here, I could go, well, I've got 16 lots of each of those, so if I went 6 plus 4, that's 10, so it's the same as 16 lots of 10. So that's going back the other way. It also works for subtraction. So even if that's the minus, if I've got the same number multiplying 2 different numbers, so I've got 3 times and 3 times, so that'll be like the brackets. I've just written the back instead of the front. And then I had 26 and minus 24, so I end up with 2 lots of 3, which is 6. You can also use the distributive law when you've got lots of a long list of additions that involve the same kind of multiplication. So you can see the 7 is in every one of these terms here. So I end up with the 6, the 2, the 3, the 5, and the 4, all here adding and then multiplying by 7. So that would be 20 times 7, which is 140. So the distributive law doesn't work for division though. So if I did division like that and I tried to break it, if I worked it out properly, the 4 plus the 8 is the 12, so 24 divided by 12 is 2. But if I did it like 24 divided by 4 plus the 24 divided by 8, it ends up being 24 divided by 4 is 6, 24 divided by 8 is 3, and when I add them it's 9, so it doesn't work for division. So all of our laws are here: cumulative, different order, associative, working out that you can add in groups or multiply in groups in different ways and they get the same. Distributive law is this multiplication out of this bracket. You have this sheet now to glue in your book and you can read through, and it's kind of a summary of what's just been talked about.